Good evening, Year 9s. We're going to finish off today our discussion about the states of matter, which we began in the lesson before half term. So before half term we talked about how the arrangement of the particles, the atoms or molecules in a substance determine whether the substance is in a solid, liquid or gas state. The last bit of this topic is to look at what happens when we change state, so when we move from a solid to a liquid or from a liquid to a gas, or the reverse process. So this is something that you should be pretty familiar with from chemistry, and we probably discussed it in physics as well. So there's going to be some notes for you to take down and a little homework sheet for you to do on this. I've got a little demonstration for you here now, just to remind you. It's kind of an obvious one, but I've got quite a powerful kettle, and it's also transparent, so which is quite useful. It means we can see what's happening. So what I'm going to do is I'm going to take some water, some H2O that's in its solid state, and I'm going to stick it in the kettle. And I'm going to switch it on, and then we're going to talk about what's happening while that does its thing. So here we go. So turn the kettle on. This should happen fairly quickly actually, because it's quite a powerful kettle. But at the moment we've got the water in its solid state. As we're putting energy in, the first thing that's going to happen is we're going to heat up the solid blocks of ice. Very quickly they'll get to the melting point, 0 degrees centigrade. At that point, the energy that's going in, instead of rising the temperature, it will break apart or loosen the bonds between the particles and the solid. That's when we have melting, and you can see that's already happening, so it's happening incredibly quickly. So we've changed state from a solid into a liquid. So that happens at a constant temperature of 0 degrees centigrade. Once that's complete and we just have liquid water in the kettle, we're fairly close to that already, the temperature will start going up again, and it will rise until we get to 100 degrees Celsius, which is the boiling point of water. At that point the water will start changing into water vapour. Same kind of idea, it's actually happening already, that's how quick it is. I'll keep my finger on the switch without burning my finger. There we go. So we can see three states of matter there. We started off with ice, we went to a liquid, and now coming out you can see there's water vapour coming out. Now I'm not going to hold my finger on the switch for much longer because it might damage the kettle. But if I was to carry on boiling the water, eventually all that liquid water would turn into water vapour, and it would obviously run dry. So putting energy into a substance changes its state. First of all, it loosens the bonds between the particles and the solid, and then finally at the boiling point it breaks the bonds apart completely and changes a liquid into a gas. That's a completely reversible process. Okay, it's not a chemical change. It's a physical change. We haven't changed anything about the substance. We had H2O to start with. We've still got H2O now. If I take this water, which at the moment is very hot, and stick it back in the fridge, it will eventually turn back into ice again. So it's a completely reversible process, change of state. So the reverse, obviously, of boiling is condensing, when we go from a gas back into a liquid again. I don't know if we can maybe see condensing, possibly. If I take this beaker, if I take this jug, which is a bit cold, and then I stick this on, let me see if we can get some condensation happening. So there's some steam coming out now. Fortunately, it's a little bit hot. It's really quite hard to do. Yeah, you can probably see it a little bit. Okay, I'll hold that there. You can probably see that there is liquid. Okay, there we go. So some of the steam that came out, some of the water vapour, I should say, that came out did condense on the cold jug. So that's the reverse process of boiling, is condensation, and the reverse process of melting is freezing. When you're going the other way, of course, you're taking energy out, so you're removing energy. I should let you know that when you cool down a substance and it changes state, rather bizarrely, it stays at the same temperature while the state is changing. So if I was to, for instance, cool down water from 20 degrees to -20, it would cool down from 20 degrees to 0, and then it would stay at 0 for a while the liquid water changed into solid water. There's a reason for that. When we melted the water originally, we put energy into the ice to melt the water. We could call it latent heat. Rather than raising the temperature, it changed the structure of the particles, it loosened the bonds between the particles. That energy was still there in the water when it was in its liquid state that we had put in while we were melting the ice. However, when we cool the water back down again and turn it back into ice, at the point of the change of state, that energy gets re-released. It gets released back. And even though you're taking energy out, the energy gets put back in at the same rate. So the temperature will stay constant while the change of state is happening. And only once the water has turned into ice will the ice then start cooling down. So that's an important thing to understand as well. There is in the end of the notes, there is a little bit about latent heat. Now there is a mathematical definition of latent heat. It's the amount of energy required to change the state of 1 kilogram of a particular substance at a constant temperature. We'll cover latent heat in full in year 10. However, I'll give you a bit of an advance warning, there is a question that does involve this on the end of topic test. So we are bringing it in now, even though it is explained in that particular question. So latent heat is the amount of energy required to melt 1 kilogram of solid into liquid. There is another latent heat, which is the energy required to boil 1 kilogram of liquid into a gas, and it's a different amount of energy. For water, the latent heat of fusion, which is the melting latent heat, is 334,000 joules per kilogram. So if you know the number of kilograms that you're melting, you just multiply that by this number, the latent heat of fusion, and you get the total amount of energy in joules that you need to melt a certain amount of ice. And of course each substance will have its own value for the latent heat. The other thing as well is, of course, each substance will also have its own different melting point and its own different boiling point. Water is 0 degrees Celsius and 100 degrees Celsius. Oil is a different, alcohol is different. Okay, each different substance will have its own different melting point and boiling point. Okay, and that's to do with the chemistry of the substance. Okay, so that's basically it on changes of state. That's all you really need to have to learn about as far as year 9 is concerned. So have a look at the notes, make some notes into your book, and have a go at the homework. I'm going to put Wednesday down, I think, as the date of the homework. I will see you on Tuesday for the Zoom lesson, and we'll think of something to go through then. May come up with a little quiz or something for you. But until then, we'll let you get on with this, and we'll see you on Tuesday. Thank you.